Okay, alright. Add it up. Okay, alright.
Well, good morning. Good morning, everybody. I am sure I look a mess right now, but I wanted to come back to you guys. A couple of things that we're going to be doing. So we're going to transition from the 100 Days of Code coursework. I did go through some additional aspects of that, and that's not in the direction that I'm going. I'm trying to work on my Comptia Data Plus certification. So first things I want to do is point out a couple of things, okay? If you are not familiar with this Data Plus certification, because this certification from Comptia is very new, I thought we would just talk about it briefly here for a moment, and then we'll kind of, work from there, if you will. So here's the thing. This was just recently launched, like February 28th. And what this is for people like me who are into data analytics and data. As you guys know, I am going to school right now, and my major is not data analytics. It is working in cybersecurity at the moment. But my minor is in data science. So that's what kind of turned me onto this, and I've just been enjoying studying data science for like the last almost half a year. So I wanted to walk you guys along. So that's why I turned this into a study group. This is primarily going to be for people who may be looking to take this test, or even just kind of interested in what it's all about. So what I plan to do is come on and study, probably roughly about 5 o'clock, 5:30, somewhere in that range. Usually it'll be probably more on the 5:30 side, and then we will study until somewhere in the 7 o'clock range. So that gives us enough time to study together. There is an area where you can ask questions, or even if I end up getting people who asked on the YouTube channel or whatever, that's fine too. But I just wanted to go through it right now. LinkedIn Learning, if you have never used LinkedIn Learning does have a preparation course for it. So right now, the book for this has not even come out yet. I still have to wait until, I think it's not until April, when the book will come out. So that should be pretty interesting. But this is what we're going to study off of until we get the book, and then we will start going through book details in the study group once that book arrives. But I just wanted to brief you on what we're doing and where we're at, and so that's what we're going to be doing. We're going to be doing Data Plus certification. I'm going to walk you guys through it as I'm learning the data. It will help me to have someone to study with and for accountability. So, okay, let's get started. I did do some work yesterday when I found this learning path, so we're just going to work on that.
Jurisdiction requirements and data breach reporting. The second objective requires that you be able to apply data quality control concepts when you're given a scenario. These include understanding the circumstances to check for quality and the use of automated validation techniques. You'll need to understand the 5 dimensions of data quality: data consistency, data accuracy, data completeness, data integrity, and data attribute limitations. You also need to understand data quality rules and metrics and methods used to validate data quality. In the third objective, you'll need to explain master data management concepts. This includes the processes used to consolidate multiple data fields, standardize data field names, and developing data dictionaries. You also need to understand special circumstances that require master data management, including mergers and acquisitions, compliance with policies and regulations, and a desire to streamline data access. Successfully mastering the three objectives of this domain will provide you with all of the information that you need to know to answer Data Plus exam questions related to data governance, quality, and controls.
Okay, so one thing that he's pointing out here is he is going through all of the domains for the test. So the test is broken down into data concepts and environments, data mining, data analysis, visualizations, and then this aspect that he's going through, which is data governance, quality, and controls. So he's getting this information primarily from the exam details here. So I know I have the exam details. They are listed here. So we can just kind of go through them. These are the parts he was talking about, and this is the way the exam is broken down. The guy that is talking in the course is Mike Chapple. He is a professor, but he also writes tons of books on IT. Like, he's got years of IT experience, but one of the things that he did write was he is the one who wrote the Data Plus book that I'm waiting to come from. Speaking of, we can check it. Okay, so his book is right here. And as you can see, I actually purchased this book or pre-ordered it long before I ever found out that it was out. But Mike is the person who wrote the book, if my memory serves me correctly. Yes, see, Mike Chapple. So he's the one who wrote the book, and that's the book that we're going to study from when it comes out. I'm just waiting. It's not even due to be released until April 12th, so we've got some time to work together. But nonetheless, this is the part where he's talking about this exam is 90 questions. Okay, you have basically an hour and a half to take the exam. You've got to score a 675 out of on a score of 1 to 900, and so you basically have to get 675 in order to pass. The test is $239. So for those of you, one thing I do know with this exam is that if you don't have a way to pay for this exam, for example, they do have different ways that you can pay over time. So it's not all just set up the same way. So just be aware of that situation. Do understand there's one other thing, like they do have a firm here. So if for some reason you can't pay for it, the voucher, because you got to buy the voucher so that you can schedule the exam, just like any other Comptia exam. But let's get back and figure out what Michael is talking about. I just wanted to go over those exam objectives that he's talking about, so it would make a little bit more sense.
The fifth domain of the Data Plus exam, data governance, quality, and controls, makes up 14% of the questions on the test. This domain has 3 objectives. In the first objective of this domain, you need to summarize important data governance concepts. These include access requirements, security requirements, storage environment requirements, use requirements, entity relationship requirements, data classification, jurisdiction requirements, and data breach reporting. The second objective requires that you be able to apply data quality control concepts when you're given a scenario. These include understanding the circumstances to check for quality and the use of automated validation techniques. You'll need to understand the 5 dimensions of data quality: data consistency, data accuracy, data completeness, data integrity, and data attribute limitations. You also need to understand data quality rules and metrics and methods used to validate data quality. In the third objective, you'll need to explain master data management concepts. This includes the processes used to consolidate multiple data fields, standardize data field names, and developing data dictionaries. You also need to understand special circumstances that require master data management, including mergers and acquisitions, compliance with policies and regulations, and a desire to streamline data access. Successfully mastering the three objectives of this domain will provide you with all of the information that you need to know to answer Data Plus exam questions related to data governance, quality, and controls.
Yeah, we're enjoying the course so far. We will deal with that situation a bit later. Which one of the following is not one of the 5 dimensions of data quality? I'm assuming confidentiality. Analytics reports should follow corporate style guidelines. My guess would be yes, but which one of the following is a measure of dispersion? I have no idea. That was a guess. I did not know that. APIs. Which one of the following is not a common data integration tool? I don't know what that is. It's probably wrong, but let's go back to the data mining.
The second
class.
domain of the Data Plus exam, data mining, makes up 25% of the questions on the test, and it has 4 objectives. In the first objective of this domain, you need to explain data acquisition concepts. These include understanding data integration concepts like ETL and ELT processes, data loads, and the use of APIs, and you'll also need to understand data collection methods such as web scraping, the use of public databases, web services.
Okay, so ETL. I would guess this one, because these are other ones. So ELT, ETLs, and APIs were part of that. Which one will follow the common data warehouse schema? I'm gonna go Snowflake.
Many people take the computer-based Data Plus exam at a Pearson VUE testing center, probably not far from their home or office. These centers, typically located in office buildings and strip malls, are nondescript locations that conduct testing for a wide variety of programs. If you choose to take the exam in person, you might find yourself sitting for the exam wedged in between a healthcare professional tackling a nursing exam and a student tackling a graduate school admissions test. Now, when you arrive at the test center, you'll go through a check-in process at the front desk, where the exam staff will check your identification, take your photograph, and electronically capture your signature. You'll need to bring 2 forms of identification along with you to the testing center, and you won't be admitted to the exam without them. Your primary identification must be a government-issued identification card that contains both a photo and a signature. For example, you might use your driver's license, a national or state-issued identification card, a learner's permit if it contains a photo and signature, a passport, a military identification card, or a non-resident alien registration card. If you have 2 items on that list, you're good to go. If you can only come up with one of those items, you can use any other form of identification for your second source. Now, any form of identification that you use must be current, not expired, and it must contain your name and either a photo or a signature. The first and last names on your identification must exactly match the first and last names on your test registration. If you recently changed your name, you must bring proof of a legal name change with you to the testing center. After completing the identification process, you may have to wait a short time until your testing station is ready for use. Once it's time to sit for the exam, you'll be asked to use a locker to store any personal items that aren't allowed in the exam room, and then you'll be shown to the system where you'll take the test. The testing software used for the DataPlus exam is the same software used for many exams administered by Pearson. You'll have up to 90 minutes to navigate through the exam, and you are allowed to return to previous items and make as many passes through the questions as you'd like during that time. If you have any questions or technical difficulties during the exam, raise your hand and a proctor will assist you. But remember, the proctors administer many different types of exam, and they have no specialized knowledge of data analytics. They can help you with the software, but they cannot and will not discuss any exam questions with you. You may take breaks at your own discretion during the exam, but the clock will not stop. You may leave the testing room, but you may not leave the testing center during your break. You also may not open your locker or access any of your belongings. If you leave the room, the proctor will re-verify your identity before allowing you to return to the test. When you complete the exam, you'll check out with the front desk, and the exam proctor will give you a score report indicating whether you passed the exam. Comptia will also send you an official notification of your results by email. Comptia also offers an online testing option that allows you to take the exam from your home or office. If you do take the test online, you'll be administered the exam by a remote proctor who will check you in, verify your identification, and monitor you during the exam, just like an in-person proctor would. They do this by using software that takes control of your computer and your webcam. If the proctor spots an anomaly, they're going to interrupt your test and try to resolve the situation. You should know that taking the test online requires that you be in a closed, quiet room by yourself with no access to papers or other reference materials. The proctor will ask you to move your webcam around to show a 360-degree view of the room and approve it before allowing you to begin your test. Some candidates have had trouble accessing the test and running the software. If you want to take advantage of this convenient home testing approach, I strongly encourage you to run the system test available from Pearson VUE before you spend the money to register for the exam. This will let you verify that your computer is compatible with the testing software before you pay the registration fee. If you have any trouble, you might want to choose the in-person testing option instead. The DataPlus exam contains two different types of questions: standard multiple-choice questions and some specialized performance-based questions. Let's look at each of these two categories. The multiple-choice questions are usually pretty straightforward. For most of them, you'll simply be presented with a fact-based question, such as the one shown here, and asked to choose a correct answer from 4 possible choices. The second type of question you'll face is the performance-based question. On some Comptia exams, like the A+ exam, you might be asked to perform a task on a simulated computer system. Fortunately, the DataPlus exam doesn't currently include these tasks. Instead, you'll find questions where you're asked to drag items into the right order, sort things by category, indicate different components of a data analysis, or perform similar vendor-agnostic tasks. When you're answering exam questions, remember to use solid test-taking strategies. Here are a few pointers. First, read the question very carefully. Pay attention to exactly what the question is asking, and remember that one or more of the wrong answers may be based upon common misinterpretations of the question. Don't get tricked by the exam because you didn't read the question closely enough. Second, read all of the answer choices before you commit to the correct one. If you're unsure of the correct answer, try to eliminate one or more of the answers that you think are obviously incorrect. If you can eliminate 2 of the answer choices, you just improved your odds of getting that question correct from 1 in 4 to 50-50. Third, answer every question, even if you have no idea what the question is asking you. There's no penalty for guessing on the exam, so you might as well give some answer for every question. Fourth, the exam software offers you the ability to move back and forth between questions and revisit those that you're unsure of. You can mark questions that you'd like to review later. Be sure to use that feature. If you're not confident in your answer, go back later and give it another read. Finally, make at least 3 passes through the exam during your 90 minutes. Taking a quick first run through the exam and knocking out the easy questions will build your confidence and help you get a feel for the contents of the entire exam. I've heard from many test takers that they've encountered exams where all of the performance-based questions appeared in the beginning of the exam. If you don't do a quick pass through the entire exam, you might become very discouraged because these performance-based questions tend to be more difficult and time-consuming. It's absolutely fine to just skip them entirely during your first pass. During your second run-through, try to answer every question on the exam. Then, your third pass will help you clean up any errors that you made. Answering other questions during the first and second passes might also jog your memory and help you answer questions that were sticking points earlier in the exam.
But this isn't the first exam I've taken.
Once you complete the Data Plus exam, you'll immediately receive an unofficial score report from the test proctor. First, be thankful for this immediate feedback. I remember taking some certification exams years ago that were paper-based exams that required you to travel to only one of a handful of cities that offered a test on a specific day. After you sat in a hot hotel room all morning, you simply turned in your test and went home to await your results. 6 to 8 weeks later. Things have come a long way. Now, people often ask me about the passing score on the Data Plus exam, and I have one typical response. You shouldn't focus on the passing score. Just prepare well and do your best. But honestly, that's generally not a satisfying answer. So, to pass the exam, you have to score at least 675 points on a 900-point scale. You'll see your scaled score on the score report.
675.
But here's the catch. This number doesn't really mean very much other than to indicate whether you passed or failed. You can't convert your score to a percentage if you're trying to determine how many questions you missed. That's because the Data Plus exam uses a weighted scoring process. Some questions on the exam are more difficult than others, and different candidates take different versions of the exam. Therefore, the exam is weighted so that each test has equal difficulty from a scoring perspective. If you don't pass the exam on your first try, don't worry about it. This happens to many people. Chalk your first exam attempt up to experience and try again. Now, I suggest registering for the retake immediately after you leave the exam center because it gives you an important mental focus. Don't dwell on the exam that you didn't pass. Nobody will ever know. Just get right up, dust yourself off, and try again. Now, one piece of advice. If you look on your score report, you'll find a listing of the exam objectives where you answered questions incorrectly. As soon as you leave the test center, read these objectives and jot down any notes about what you remember from those questions. You'll likely forget this information quickly, but if you record it, you'll be able to use those notes to help study for your next exam. You can take the exam again as quickly as you like. Just register for a second appointment following the same process that you used to register for your first exam. If you need a third chance, you'll have to wait at least 14 days before taking that exam for the third time. But don't worry, after completing these courses, you'll be ready for the Data Plus exam. I've helped hundreds of thousands of people prepare for their certification exams, and I'm glad that you've decided to follow this same journey. Over my years in the field, I've heard feedback from many different people who have taken the exam, and I'm glad to be able to offer you some of the knowledge I've gained in this series of Data Plus courses. As I've worked with students, I've noticed quite a few trends in the way that exam writers formulate questions and focus on specific topics that lend themselves to test questions. I've also picked up on the ways that question writers try to trick students into choosing the wrong answer choices. I've worked this knowledge into these Data Plus courses. Whenever we cover a topic that has some tricky information or details that I think you really need to know for the exam, I'll call it out using an exam tip. When you're watching the other courses in this series, keep an eye out for the screen with this graphic. When you see it, pay careful attention because I'm about to share with you some of the knowledge I've gained that will help you succeed on the Data Plus exam.
What would be an example of an acceptable form of primary identification? So you can use your passport. Yeah, you can use your passport. Wait.
Thanks for watching this course.
I didn't get a chance to take the quiz yet. Okay. What is the minimum passing score? 675. You only have one opportunity to answer each question. No, you're not just one opportunity. Really? Oh, I actually, literally, really? I said that's not true, but hit the true button. How much extra time is allowed compared to the in-person? I didn't think it was any. I don't recall there being any. I thought it was the same. Okay, so we can take the passport. We know that's correct. 675. We know that's correct. You know, that is actually correct. And I don't recall there being any specific time extra.
Thanks for watching this course on preparing for the Comptia Dataplus exam. I hope that as you've completed this course, you found it interesting and also helpful in preparing for the Dataplus exam. You should now have all of the background information that you'll need to begin your studies in earnest. From here, you can move on to any of the other 5 courses in this series. If you like tackling things in order, dive right into the first domain with the Comptia Dataplus Data Concepts and Environments course. Otherwise, choose the course that interests you most and begin there. Good luck with the rest of your test preparation.
All right, so we are going to add it to our profile. All right, and we're adding that to the profile. We don't need to, we have that information there, so we don't need to download that. All right, so let's go back. We now need to finish this, and we're actually going to restart this because I worked through some things here earlier, and as you can see, I got like 22 minutes left on it, but we're going to go all the way back.
From simple data collection and management to complex analytic efforts, today's businesses run on data and depend upon that data to achieve business value. That creates a significant demand for skilled and talented data analysts. Comptia's Data Plus certification is a path that many professionals follow to advance their careers in this high-demand field. Hi, I'm Mike Chapple, and I'd like to invite you to watch my course on data concepts and environments. It's part of a 6-course series preparing you for the Data Plus exam. I hope that you'll join me as we explore the basics of data and data management. I've designed this series of Data Plus courses with the beginner in mind. While you'll probably find it a little easier to complete this course and the Data Plus certification if you've worked with data before, that's not a requirement. If you're looking to get started in data analytics, this course series will provide you with all the information you need. If you're a technology professional with some data experience under your belt, this course series will help you fill in any gaps in your knowledge and build a solid foundation as you prepare to take the Data Plus exam. In today's economy, information is one of a business's most valuable assets. From product plans to customer records, every business has sensitive information, and protecting that information is a crucial business concern. In the right hands, data can be an invaluable business tool, However, if that information
Ah,
falls into the wrong hands,
I need to get
it
some
could
more
damage
water.
the organization's
Got like
reputation,
some, but I
injure its
really need to get
customers,
some more
or
water.
cause financial losses. As a data professional, you're responsible for protecting the information that your organization values, and the first key step to that is recognizing that data and information are assets that have value to the business, just like your vehicles, buildings, and other equipment. Now let's talk a little bit about the difference between data and information. Data are the raw facts that our systems and processes generate and collect on a regular basis. You can think of data as just bits of knowledge. For example, we might put a thermometer in our factory to monitor a piece of sensitive information. That thermometer might record a temperature reading every 10 minutes to determine the temperature inside of the equipment. The end result would be a spreadsheet or a database table containing all of the temperature recordings over time. Each one of these temperature readings is a fact, and all of this together is data. We have a spreadsheet providing data about the temperature readings of this equipment. Now, information is data that has been processed and analyzed. A system or a person has put some effort
I'm not
into
bored
putting
by you
that data
guys,
in the
so
context of the
don't think
business
that at
so that
all.
it's more useful to us. Now, a spreadsheet of information about temperature might be correct,
I
but as
recently
it is, it
decided
isn't very
to
useful. It's
start
just a collection of data
fasting,
that isn't
and
put
so
in
I
any
started
context.
yesterday.
But look what
And
happens if we
I
create a
am
plot showing how the temperature of
just
this
about,
equipment
I think,
changes
what,
over time.
a
Now
little
we
over
start to
12
share some
hours.
information.
So
Looking at this chart, we
we're
can
going
quickly
into
see
the
that the
next
temperature in
stage
this
of it.
machinery
So
spikes to
so
very
far it's
high
been
levels
cool.
every afternoon around 2 p.m. That's information that we can act upon. We can tell the people responsible for this equipment that they need to figure out what's going on every afternoon and determine whether this is causing a dangerous situation. Now, that story is an example of a data-driven business decision. When we have the right information at our disposal, we can act upon it to improve our business. Now, there are a few stages to this process. First, we capture and collect data that might have meaning to our business. Whether that's temperature data like our previous example, data about our customers, products, or the operating environment, there are many different kinds of data that might be valuable to us. Once we have that data, we can correlate it, performing analysis to help find the meaningful information that it contains. And with that information in hand, we can provide reports to business leaders, helping them make data-driven business decisions. When you think of data, chances are that you immediately think of spreadsheets like Microsoft Excel. Spreadsheets are valuable tools that allow us to organize our data in tabular form. That tabular format is an easy way for us to think about our data, and it is the most common way that we store data for use in analytics. This approach, where we store data in well-defined tables, describes a category of data known as structured data. Now, we not only find this structured approach to data in spreadsheets, but we also find it in relational databases. These relational databases allow us to create many different tables of data, each containing information about a single type of person, object, or event. Database designers then create relationships between those different tables that describe how the data interacts.
No, you're not late. Come
Here's
on
an
in.
example of a very complex database schema. This
We're
is the
just
schema for
starting.
the Adventure
We're
Books
just getting
database,
started with
a
the study
database
group,
designed by
so
Microsoft
fine.
to mimic the operations of a bicycle manufacturing company. Each one of the boxes on this diagram represents a different table of data, and each one of the arrows represents a relationship between two tables. Now, don't worry too much about this diagram. We're going to come back to the concept of relational databases later in this course. For now, I just want you to understand that most of the data we use in day-to-day business operations is highly structured. At the other end of the spectrum, we have unstructured data. This is data that doesn't neatly fit into the table model. For example, we might have a collection of photographs, video recordings, word processing documents, or other data sources where users simply enter or collect data without the highly structured framework of a table. Now, while it's true that most of the data that we use in analytics is structured data that does live in spreadsheets and databases, most of the data that actually exists in the world today is unstructured. It lacks the defined fields of these more structured data sets. Unstructured data often comes from machine data sources. Internet of Things devices, smartphones, tablets, personal computers, and servers all create digital footprints of their activity, and they often do so in unstructured form. This data can be a treasure trove for analysts seeking to find new data sources for use in their analysis, and organizations that really take advantage of their unstructured data can achieve a real competitive edge. Now, we like to put things into clear categories. and it's tempting for data professionals to try to describe any data source as either structured or unstructured. But the reality is that data resides on a spectrum, where it can range from highly structured, such as a database table, to highly unstructured, such as an audio recording. There's also plenty of room in between for data that has elements of structure, but retains some unstructured elements. You'll see some examples of this as we work our way through this course. Spreadsheets may be powerful tools for storing data in tabular form, but they have some limitations that prevent them from being a useful tool in enterprise data management applications. That's where databases come into the picture. Databases extend the concept of storing data in tables from the single table-focused spreadsheet model to the relational model, which focuses on how tables interact with each other. Here's another look at the schema diagram for the AdventureWorks database that I showed you earlier. Each one of the boxes on this diagram represents a single table, and each arrow on the diagram represents a relationship between two tables. Now, can you imagine trying to track all of this information in a series of spreadsheets? You might be able to do it, but it sure wouldn't be much fun. In the relational model, we still organize our data into tables, and each table contains information about a single subject or topic. Here's an example of a table that we might use to track information about the customers of a business. The subject of this table is customers, and you don't see any information in this table that doesn't relate to a customer. There's no inventory information, weather data, store phone numbers, or anything else that doesn't relate directly to customers. If we need to track those other types of information, we put them in different tables. Each column in a table is called a field, and it contains information about a single characteristic of the subject. For example, we have columns here for customers' first name, last name, street address, and other attributes that we'd like to track about our customers. Each row in the table is called a record, and it contains information about a single instance of the table subject. Here, our table subject is customers, so each row corresponds to an individual customer. The first row is about Suzanne Viescas, the second row is about William Thompson, and so on. This is how databases extend the relational model used by spreadsheets. Data is still organized into single subject tables, with each column representing a characteristic of the subject, and each row representing an instance of the subject. Key value pairs are an example of a semi-structured approach to data storage. They provide a very lightweight way to store data that throws away many of the rules of relational databases. Key value pairs don't have to be organized into tables. The only requirement is that we have a key that can be used to index the data, and one or more values that we wish to store in the database related to that key. Each record can have different values and even different numbers of values. Key value stores are databases designed specifically to provide efficient storage and very fast retrieval of key value pairs. Key value stores are often used in applications where the data is simple, and the most important feature of the database is being able to get at that information very quickly. Here's a simple example of a table created in DynamoDB, a key value store from Amazon Web Services. This one contains some simple information about individuals and their skills. Notice that different people have different numbers of skills. When you first look at this table, you might think that it simply has fields labeled Skill 1, Skill 2, and Skill 3, and that the last field is blank for people who only have 2 skills. However, if you look at the 2 records that I've included on the right side of the screen, you'll notice that Hercules Mulligan actually only has 2 skill items associated with this record. There is no Skill 3 item in that record. In this simple example of a key value store, the employee ID is the key, and all of the other fields are values associated with that key. Here's a more complex example from a research project that I'm working on. This is a key value store containing pricing information for used books on Amazon.com. We're doing a research project on this pricing data, and we receive updates from Amazon anytime one of the books in our study has a price change from any of the 20 merchants selling that book at the lowest cost. This translates to hundreds of thousands of records per hour. Now, if we tried to store that information in a relational database, it would be incredibly expensive to build a database that's capable of processing and storing information that quickly. Instead, we're using a key value store that has a multi-part key: the ISBN of the book, which is called the ASIN here, and the timestamp of the record. Now this is very efficient for us because we only need a small fraction of this information later, but we don't know in advance what information we're going to need. When we later need to process a record, we can quickly scan the key value store using the ISBN and the time period in question to get a view of what the used book market looked like at that moment in time. Now, those are two examples of the ways that we can use key value pairs in a non-relational database.
Yay,
But
JSON
key value
files.
stores aren't the only place that key value pairs appear. Later in this course, you'll see how they also appear in JSON files.
All right, so we'll look at the answers, and we should probably retake this quiz because we didn't do it right. What is the maximum number of values that may be assigned to a single key in a value store? I don't remember him saying that there was a maximum. Maybe I am correct. He recently downloaded a file containing website visitor logs from an organization's web server. What term best describes these logs at this point in the process? It's just a data point, but it's probably information. But in a tabular data set, what term is used to describe the data that appears in a single row? A field. Let's go back.
Spreadsheets may be powerful tools for storing data in tabular form, but they have some limitations that prevent them from being a useful tool in enterprise data management applications. That's where databases come into the picture. Databases extend the concept of storing data in tables from the single table-focused spreadsheet model to the relational model, which focuses on how tables interact with each other. Here's another look at the schema diagram for the AdventureWorks database that I showed you earlier. Each one of the boxes on this diagram represents a single table, and each arrow on the diagram represents a relationship between two tables. Now, can you imagine trying to track all of this information in a series of spreadsheets? You might be able to do it, but it sure wouldn't be much fun. In the relational model, we still organize our data into tables, and each table contains information about a single subject or topic. Here's an example of a table that we might use to track information about the customers of a business. The subject of this table is customers, and you don't see any information in this table that doesn't relate to a customer. There's no inventory information, weather data, store phone numbers, or anything else that doesn't relate directly to customers. If we need to track those other types of information, we put them in different tables. Each column in a table is called a field, and it contains information about a single characteristic.
It's probably record. Yeah, okay. Most data that exists in the world is structured data. That I do not believe is true. Okay. We have just about 2 minutes before we're going to go on a quick break. So when the break starts, just so you guys know, since this is the first time that you may be hanging out with me in the study group. So what we do is called a Pomodoro technique. So we go for 45 minutes studying, and then you will get either, in this case, I believe that the break is set up for 5 minutes. Typically, it's either a 5 or a 10-minute break, depending on how you're working. And you will get that. You can go get coffee, water, that type of thing. And then you can come back. And so I just want to let you know that, because you will see the scene will change as well. It will go from the screen that's here. You will often hear like rain, and you will hear music that will let you know that it's time to get up, stand up, so you're not just sitting at a screen for 2.5 hours, just sitting here watching me click through. That's boring. That would be boring for me to watch as well. So I'm just letting you know. when we get to that point and you hear it switch over, just go ahead, um, stand up, get you some water, check your phone, all of that thing. I believe that the first one that we have, but I have to look at it, I think it's actually 10 minutes. And then the second break that you get is only 5 minutes because this is usually designed to be like a 2-hour stream. This was designed to start at 5 a.m. and it's 7. So that's the way that it typically will work. And for the most part, as we go through, if you want to come in, some people prefer to come in the second half of the study session. I appreciate you guys being here and kind of going through the process with me. So I won't start this next section because we're just about, like 30 some seconds. There's always a timer, by the way. There is always a timer that is on the system. I feel like you guys are kind of like crooked, but I know you're not. But I just feel that way from the camera here. Anyway, there is always a timer that's at the bottom that will go through letting you know where we are. Obviously, some people may not even know what that's for, but that's keeping track of our time, so it lets you know how long we have in the course. So there's our break. That's what it will look like, and this is a 10-minute break. So get up, go get you something to super loud. All right, welcome back, you guys. I did switch you to a different screen. So for most of you guys, it was time to switch you to a different screen. So let's go ahead, continue on. This is our second 45-minute block. So we will go there. So that's a good thing. Hey, welcome. Thank you so much. I appreciate you coming through, and I appreciate that you came by and see me. Thank you so much. I do really appreciate it. All right, so let's go through
As
to
we
our
begin
next
our
one.
exploration of the world of data, let's dive into the major types of data used in analytics. Each data object stored in a database or used by an application has an associated data type that tells the computer how to handle it. That's how we tell the difference between numeric values, character strings, and other types of data that we might have stored in memory or on disk. Numeric data is, as the name implies, data that uses numbers. You might use a numeric data type to store the number of products that you have remaining in inventory, the weight of a person in pounds or kilograms, the length of a boat, or any other value that we can measure quantitatively. Now, there are two major subtypes of numeric data. Integers are values that do not have decimals or fractional values. They're whole numbers such as 1, 2, and 3. And they can also take on negative values such as negative 123. Floating point numbers, or floats, are numbers that do have decimal places associated with them. They're decimal numbers. The precision of a floating point number indicates how many decimal places may be used with that number. The more precision we use, the more memory a floating point number consumes, because the computer has to store the values that are kept in all of those extra decimal places. Currency values are a special data type designed for storing information about money. The format of currency values varies depending upon the specific currency being used in a location. Now, these currency values are typically stored using integer values, but then the database storing them reformats them to display them in the appropriate local currency when they're used in reporting. This approach helps reduce rounding errors and other small inaccuracies that may result from
Actually,
using
I
floating point
just
data
realized
types to
something
store
in this
currency
process.
values.
We
We
only have
also
about 30
commonly work
minutes
with
because I told you
text
guys
data.
I
That's
was
data made up of
shutting off at 7
characters.
o'clock
We use
today.
text for so many
So
different
7
purposes,
a.m.
ranging from
Central
small
Standard Time
fields such as
will be
people's
ending the
names or
stream.
addresses to large
And
blocks of
so
text that might make up a
I just wanted
paragraph,
to let
an
you guys know
article,
because I
or
looked at
even
the
an
time and I'm like,
entire
oh, we
book.
got 40 minutes.
Computers
But
store
again,
text
the
using
stream
a
was
data
set up
type
for
known as a
5
character
a.m., which
string.
is probably
This
what I'll
simply
stick
means
with.
that it is a sequence or string
So
of
just
one
letting
or
you
more
guys know
characters put
that I
together
know
to
it says
create a block of
45,
text. You can
41
create strings
plus
of
minutes or
different
something
lengths
like
in
that.
databases,
But we only have
spreadsheets,
about
and
30
programming
minutes left.
languages. Now,
And
character
at
strings
7
may
o'clock, we'll
contain
go
either
ahead
plain
and
text
break out
consisting
for
of only
today.
letters and symbols,
And
or they
then
may
we'll pick up
contain
again tomorrow.
alphanumeric text that mixes together numeric digits with letters and symbols. One important thing to understand is that if you have numeric data stored in a string, you can't perform mathematical operations on that data. And the data might look like a number to us, but to the computer, it's simply the text characters that make up those numbers. One really interesting and tricky example of this are the zip codes that we use in the United States. These are 5-digit numbers that uniquely identify a town or an area of a city for the delivery of mail. Since they're numbers, you might be tempted to store them using a numeric data type. However, the problem is that many zip codes start with the digit 0. If you store those in a numeric data type, the computer will ignore the leading 0 and truncate the zip code to be only 4 digits. For that reason, you should always store zip codes as text. Now, you may know that computers store and process data in binary form.
Didn't
They're
know
very
that.
good at working with
Actually, we
numbers,
should
but when we want to store
probably
text data, we need to provide the computer with some way to represent
we
that
should
text
probably
in
make
numeric form.
sure that we note that as like in a notebook because you want to make sure you store zip codes. Always store zip codes, he said. As text. Text and not data because the computer cannot read the leading 0. Okay, interesting. Didn't know that. But we are going to make sure that that was taken. So I just want to make sure that's noted before we proceed forward, because I didn't know that you needed to do that as a leading, because it would omit the leading zero. I never knew that.
Form that the computer can easily store. We do this by using standard codes to describe how we encode each character as a number. When we're using English or another language that uses the same alphabet, we use a code called the American Standard Code for Information Interchange, or ASCII. This code describes what numeric value to use for each of the uppercase and lowercase letters, digits, punctuation, and other symbols commonly used in the English language. ASCII was originally designed as a 7-bit code, but modern computers use an extended version of ASCII that uses 8-bit bytes. Now, if you're working in languages other than English, you need to have more characters available to you. This requires the use of a different code system. Unicode is a larger character set capable of representing thousands of different characters using either 8 or 16 bits of data.
Interesting.
Another way of thinking about our data is whether it comes in discrete or continuous form. Discrete data is data that may take on values that come from a limited set of possibilities. Now, these possibilities may be numbers or they may be text-based categories, such as country of birth, vehicle color, or a person's favorite baseball team. Continuous data, on the other hand, is data that may take on any possible numeric value within a range. Now, there are infinite possibilities for continuous data elements. For example, consider the height of an adult person measured in inches. Human beings have a normal height distribution ranging from about 55 inches to around 85 inches. Within that range, an individual person can take on an infinite number of possible values. For example, I could be 71 inches tall, 71.5 inches tall, 71.52 inches tall, or even 71.52481 inches tall. We could come up with as many possible values as we'd like. One quick shortcut for identifying whether a numeric value is discrete or continuous is thinking about how you gather the data. In cases where you're counting things, the data is generally discrete. If you're counting the number of people entering a stadium, you're going to come up with a whole number, and that number is going to be somewhere between 0 and the number of people who fit in the stadium. It doesn't make any sense to have a decimal value because a half a person can't enter the stadium. On the other hand, in cases where you're measuring something, you're generally going to have a continuous value because the number of decimal places you have will depend upon the precision of your measurement. Examples of these continuous values include measuring the weight of an object or the air temperature. Now, when you have a discrete variable that uses text values, this is a situation known as categorical data. Categorical data types are used when you're grouping information into a set of buckets with a limited number of values. For example, if we divide a group of students up by their high school class year, we might have 4 categories of first-year student, sophomore, junior, and senior. Similarly, we might categorize household pets into the categories of dog, cat, bird, reptile, and snake. The important characteristic of categorical data that differentiates it from other text is that there is a limited set of values from which we can choose. A person's name, for example, would not be categorical because there are an unlimited number of possible names. You'll also commonly need to store dates and times for various data applications. These can be a little tricky because dates are written differently in different parts of the world, and different time zones also complicate the matter.
I think we need to go
also
back.
commonly work with text data. That's data made up of characters.
No.
Another way of thinking
This
about
one
our
is,
data
I
is
want
whether
to
it
take a
comes in
note here
discrete or
because
continuous form.
there is something
Discrete data,
that
71.5, it doesn't make any sense to have a decimal value.
he pointed out here that when you are counting things, you are using when you are measuring things, you're using let's see, that is discrete, that's non-discrete. All right. What did I miss on this already? Oh, okay. Makes sense then. Okay, I want to make sure that that is noted as well. So because it was just kind of rattling around in my brain trying to figure out, like, okay, when you're dealing with something that is discrete data, the part that made that easier to understand is when he was saying you're counting the number of people coming into a stadium because you can't have 0.5. But if you were measuring, let's say, a desk or something, that is going to be non-discrete data because that can have a decimal point to it, basically.
You'll also commonly need to store dates and times for various data applications. These can be a little tricky because dates are written differently in different parts of the world, and different time zones also complicate the matter. For example, all of these formats are different ways that you might write the date February 6, 2022. If you didn't know the format that was being used, you might confuse these last two, not knowing if they represented February 6th or June 2nd. To avoid these issues, we store dates using special data types that store the underlying date without regard to the format in which it's displayed. You can then choose whatever display format you'd like, but the underlying date value is preserved. Data systems also provide special data types for the storage of time values, including the hour, minute, second, and in some formats, even fractions of a second. You can also store a time zone value with the time so that the system or person interpreting the value knows what time zone is being used. Finally, date-time data types allow the storage of a date and a time together. These are commonly used for timestamps on system logs and other applications where you'd want to store both the date and the specific time of an event. While most of the data that we store in databases is in text or numeric form, we often have to work with multimedia data as well. Databases provide special binary formats that allow us to store multimedia data such as images, audio, and video. Now, people around the world armed with smartphones now take more than 1 trillion photographs every year. Some of those photographs make their way into databases where they must be converted into ones and zeros for storage in binary form. Fortunately, image formats like GIF, JPEG, and PNG take care of all of that formatting for us. Image data is useful in many industries. Doctors, dentists, and other healthcare professionals rely upon images to provide accurate diagnoses of their patients. Insurance companies store images of the damage from car accidents to assist in the processing of claims and possible lawsuits. And there are many other examples of business use of images. Audio recordings also may be captured and stored in digital form through the use of microphones and audio capture software. This data is then often compressed to save on storage space. Audio data may be used to record calls to a customer service center for quality assurance purposes, to take notes from a meeting, or to permanently record legal proceedings. Finally, video data is now widely used and stored in file formats such as MP4 and QuickTime. Applications of video data range from recording feeds from home security systems to preserving files from video conferences and storing recordings of athletic events for archival purposes. Whatever the application, video data takes a large amount of storage and it has to be carefully maintained.
Which one of the following values would not be appropriately stored as an integer data type? 0. Which one of the following values would not be appropriately stored in an integer data type? Actually, this negative wouldn't. Interesting. Okay. Let's see what
As we begin our exploration of the world of data, let's dive into the major types of data used in analytics. Each data object stored in a database or used by an application has an associated data type that tells the computer how to handle it. That's how we tell the difference between numeric values, character strings, and other types of data that we might have stored in memory or on disk. Numeric data is, as the name implies, data that uses numbers. You might use a numeric data type to store the number of products that you have remaining in inventory, the weight of a person in pounds or kilograms, the length of a boat, or any other value that we can measure quantitatively. Now, there are two major subtypes of numeric data. Integers are values that do not have decimals or fractional values. They're whole numbers such as 1, 2, and 3. and they can also take on negative values, such as negative 123. Floating point numbers, or floats, are numbers that do have decimal places as B3.
Let's go back.
Floating numbers, such as 1, 2, and 3. And they can also take on negative values, such as negative 123. Floating point numbers do not
Okay.
have decimals or fractional values, which are subtypes of numeric data. Integers are values that do not have decimals or fractional values. They're whole numbers, such as 1, 2, and 3. And they can also take on negative values, such as negative 120.
Okay. So the actual answer is this. What data type is most appropriate for storing postal codes such as zip codes, text? It's got to be a string, because that's what you would use. Float is a different thing, but which of the following data elements would not normally be stored in binary format? I don't think a video recording would be in binary format. But we're going to go see what we missed.
While most of the data that we store in databases is in text or numeric form, we often have to work with multimedia data as well. Databases provide special binary formats that allow us to store multimedia data such as images, audio, and video. Now, people around the world armed with smartphones now take more than 1 trillion photographs every year. Some of those photographs make their way into databases where they must be converted into ones and zeros for storage in binary form. Fortunately, image formats like GIF, JPEG, and PNG.
Okay, so which of the following data elements would not normally be stored in binary formats? Interesting. Because all of these, they have to convert them to a binary format. Geolocation would not normally be stored in a binary format. Which one of the following is not a good example of a discrete data type? I'm going to take temperature of a room. Okay. Let's move on.
Data scientists are often called upon to perform analysis on data stored in many different kinds of files. As a data professional, you'll need to understand the formatting of these files and be able to recognize them. Now, we'll begin our discussion with simple text files, or flat files. These files are simply text stored in a file on the disk with no specialized formatting. Unlike highly formatted files such as spreadsheets and word processing files, text files contain just that, text. The most common flat file format is the comma-separated values, or CSV file. Also known as comma-delimited format, CSV files match the standard format of a spreadsheet, but they place all the information in a text file that may be read by any program, including a text editor. Each line in a CSV file is also referred to as a row, and it corresponds to a single data observation. Now, text files don't have columns per se, so the CSV file uses commas to separate data that would appear in different columns. Each row consists of the attribute values belonging to a single observation, separated by commas. For example, take this simple spreadsheet that shows the names, ages, genders, and zip codes for a group of 3 people. This file is formatted in a fairly standard way. Each person has their own row in the table, and each table column corresponds to a single variable. If we wanted to transform this spreadsheet into a CSV file, we simply take away the table boundaries and replace them with commas. This CSV format may then be stored in a simple text file instead of a proprietary spreadsheet format. Here's an example of a more complex CSV file. This particular file contains the results of restaurant inspections conducted by the City of Chicago. It has over 140,000 lines, and we're just looking at the first few here. In this particular case, the first row contains the names of the attributes, while each of the remaining rows in the file each represent a single observation. In this case, that's a single restaurant inspection. There's one other thing I want to point out while we're looking at this file. Sometimes data in a field might contain a comma. Let me switch here to another window where I have a single line of the CSV file pulled up. This record represents the inspection of a restaurant called Steak Bar. Notice this field here that contains a listing of comments that the restaurant received during the inspection. This field contains commas in several places. If we just put that field in the file as is, any program trying to read the CSV would be confused by the commas within the field, thinking that they marked the boundaries of new fields. We correct this by enclosing fields that contain commas inside of either single or double quotation marks. So that gives you a quick understanding of how CSV files are formatted. CSV files are one of the most common formats that you'll encounter because almost every program can read them. They're the de facto standard for sharing data between systems. Let's now turn our attention to another common file format, the tab-separated values, or TSV file. Now, as you probably guessed from the name, TSV files are extremely similar to CSV files, except they use tabs instead of commas to delimit or separate the fields. Now, there's nothing inherently better or worse about using tabs instead of commas, it's just a different file format. Here's an example of a TSV file. We're looking at a file that contains about 160,000 records gathered from the U.S. government's Center for Medicare and Medicaid Services. It contains information about the average cost of 130 medical services at providers around the country. Look, for example, at the first record here. It's telling us that you're having one of these extracranial procedures and you're at the Southeast Alabama Medical Center. You can expect that they'll bill you somewhere in the vicinity of $33,000. The next line shows us that the same procedure is about half the price at the Marshall Medical Center. That's important information, and you can imagine that a data scientist might be interested in analyzing the thousands of records in this file. Now, if you look at the way this file is laid out, you can sort of tell that there are tabs in here separating the fields because of the way that the lines are spaced. The tabs just look like a bunch of spaces, but they're there in the file. You'll encounter all kinds of text files in your work as a data professional, but comma delimited and tab delimited are the two most common formats. Be sure that you're able to recognize them when you take the exam. The easiest way to do so is to notice that comma delimited files have a lot of commas separating the fields, while tab delimited files have a lot of white space that results from the tabs that separate fields. While CSV and TSV files are very data scientists are often called upon to be sure that you're able to recognize them when you take the
what he just said, because this is one of those things he gave as a note section. So CSV files normally have a lot of commas throughout the document. Text separated by commas. TSV files have data points separated white space. Okay, now we can move back on to the JSON files here.
While CSV and TSV files are very useful, they're also limited in the amount of formatting that you can use. And sometimes we need to store more complex data structures in text files or send them over the internet, and we need a more structured text format to be able to do that. That's where JSON enters the picture. JavaScript Object Notation, or JSON, is a format for exchanging structured data that's commonly used in data-driven applications. JSON uses the concept of key-value pairs that we discussed earlier in the course to create structure, but it also uses a plain text format that can easily be exchanged between systems. Each JSON object represents a single observation, and you would have multiple JSON objects for different data observations. For example, imagine that we're using JSON to exchange data about college courses. Here's an example of a JSON object for a course that I teach. It has a series of key value pairs, each containing information about the course. The first key value pair contains the department in which the course is taught, so the key is department and the value is ITAO. The second pair is the course number, so course number is the key and 40730 is the value. Next we have the course title, Cloud Computing, the professor, Chapple, and the semester, Fall. This is how a JSON object is built out of key value pairs. These JSON objects can contain a variety of data types. In that earlier example, you saw two of them. The first is the string data type. In this case, the value portion of a key value pair contains text enclosed in quotes. The second is the number data type, and there the value is a number and it doesn't appear in quotes. We can also have Boolean values as a data type. Boolean values are either true or false and do not appear in quotes. JSON objects may contain arrays, which are lists of similar elements. There are a series of key value pairs contained in square brackets. And the final data type is the JSON object itself, which is enclosed within curly braces. In complex data structures, you can have nested JSON objects, where JSON objects contain other JSON objects. Here's another example of a JSON object, this time containing information about a salesperson. The first couple of fields here, first name and last name, are strings containing text. The next field, age, contains a number corresponding to the salesperson's age. And then the salaried field contains a Boolean value that can be only true or false. Phone numbers is an array. Inside the square brackets, we see other JSON objects that are the elements of that array. The first one is for the mobile phone number, and the second one is for the salesperson's office phone number. If you see an exam question asking you to identify the format of a file, the tip-off that it's a JSON file is the presence of curly brackets and key value pairs with the keys and values separated by colons.
All right. So, there's no files. I think that is. I think that's JavaScript. It is. Because I was like, that's written like JavaScript. But that's from my classwork. So I wanted to. It was just the way it was formatted with the curly brackets. And in my mind started to recognize that from schoolwork in my last class that I went through, it's a Java class. And so I just recognized the way that that was formatted, like Java. All right, so can be noticed by the presence of curly braces, sorry. Colon, separated key values. All right, you guys, we got just about 5 minutes left. And we should be able to figure out, we should be able to do maybe one more, and then we'll call it a morning, and then we will be done again until tomorrow.
Web pages are designed using the Hypertext Markup Language, or HTML. HTML is a markup language that allows web pages to have all sorts of advanced functionality other than just displaying plain text. HTML authors can add different fonts, include images, link to other sites, and even include small programs called scripts that run in the browsers of visitors to the site. HTML uses the concept of a tag to perform all of these actions. For example, the B tag is used for bold text, the I tag is used for italicized text, and the A tag is used to include hyperlinks in a document. When you're including a tag in a web page, you write the tag inside of brackets made using the greater than and less than signs. You first open the tag, then you include your text, and then close the tag by including it again, but this time putting a forward slash in front of the tag. Here's an example of how you would bold some text, and then it would appear like this. Here's how you'd italicize some text, which would appear like this. And here's how you include a link to another site, which would then display with the familiar hyperlink formatting. Now, when you're taking the exam, you can easily recognize that a file contains HTML by the presence of standard formatting tags, such as the A tag for links, the B tag for bold text, the I tag for italicized text, and so on. These will always...
Alright, so you recognize HTML documents. By the open and close brackets. Symbols, not brackets, symbols.
always be contained within the greater than and less than symbols. Also, remember that HTML documents are used for web pages. The extensible mark...
Alright, you guys, so that is about it. We are going to end the stream. I will see you guys tomorrow. I appreciate you coming to hang out, those that showed up and asked questions and some other things. I definitely appreciate it, and you guys are amazing. Thank you so much for taking the time to come out, and I will see you tomorrow.